Hello everyone, welcome back to the channel. Today we are going to see this question called digit queries on the CSES problem set. So I've changed platform from this code forces to CSES for just the change, and the question goes as follows. Consider an infinite string that consists of all positive integers in increasing order. This is like 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10, this is 10, this is 11, then 12, such like that, till infinity. So your task is to process q queries of the form what is the digit at the position k in the string. So input is given as you are given number of test cases q, means queries, and you are given a number k, and you have to find at position k what will be the number or the digit. So let us take a look at example test cases. So here 7, 19 and 12. So our sequence is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This should be enough, I think. So test cases were 7, 19 and 12. So at 7, digit is 7. So for this test case, answer should be 7. For this one, till here it is 10th, 11, 12, 13, 14, 15, 16, 17, 18, 19. So for the k is equal to 19, answer should be 4, and for 12, answer should be 10, 11 and 12. So 1. So 7, 4 and 1, which is indeed correct. So this way we have to find at uh, k what digit will be present. So at the kth index what digit will be present, and we are assuming one based indexing. So don't forget that we are following one based indexing. So what I will do is that suppose suppose observations are like one digit numbers are 9, means there are 9 one digit numbers, there are 92 digit numbers, there are 903 digit numbers. So how much each of these sets will contribute to the sequence? So it is like one digit numbers will contribute 9 digits to the sequence, these will contribute 180 digits to the sequence, and this set will contribute 2700 digits to our sequence. So likewise, and what I will do is that it is better if we see directly the code. See, so this power function is for something I will explain. So t is number of test cases or queries, while t minus minus input is completed here, c in k. Now if k is one digit number, this is the handling of edge test case. So basically here to here, if k is one digit number, so directly automatically it will be answer. So k is equal to 7, then automatically answer will be 7. K is equal to 9, automatically answer will be 9. So after that, if it is not one digit number, so what we will do is that we will find how much digits is number k having. So how will we calculate that? So basically we will initialize number of digits as 1, and where while k minus a star till is greater than or equal to 0, means a is like 1, 1 is like number of digits. Okay, I could have used a as number of digits as well, but just for the clarity, k minus a star till greater than or equal to 0 means what I will do is that suppose I have k as suppose 5000. So I will do 5000 minus 9, then I'll do 5000 minus 9. This will be my sum answer, minus 180 then I'll do minus 2700 till this number is greater than or equal to 0. So till I'll do that, then I'll get how much number of digits are there in k. Then if k is 0, then directly I'm outputting 9. Why so? Because suppose uh, our our what you said k was 9, then you can see answer is directly 9. Okay, suppose if k was 189, so k minus 9 would be 180, and a new k which is 180 minus 180, this number. First I have decremented this number, then I will decrement this number, then this thing will become 0. When will it become 0? It will become 0 when k is at the edge of those numbers, means this 9 or this 99, 999, where there is a transition from n to n plus 1 digits in the numbers that will occur further from that number. So basically answer should be 9 in that case. That's why that if statement is added, and if k is not 0, then finally what we will do is that we will find in what number does k appear. So for that I am initializing this actual number as power, and passed arguments are 10 common number of digits minus 1. So this power will calculate the power, basically 10 a to the power of b. This will power function with a passed arguments as a and b will calculate a to the power of b. And what else? So actual number will first contain, what will it contain? So it will contain one second. So why is this pointer not visible? Yeah, so what this actual number what is this actual number initialized is that it is initialized to the number which is the power of 10 and just below the k, just below the k, not just below the k, just below the number which contains the kth digit. Okay, so that is what actual number is initialized to. Now if k is equal to number of digits, so what this signifies is that k is number of digits, means k occurs, suppose k occurs directly in that actual number, means power of the 10, right? So suppose k was what called 11, so 11 minus 9 would be 2, and the number of digits in which k occurs, the number of digits in the number in which k occurs is also 2. So if it is directly 2, then we can see that final number or final digit should be always 0, right? So because it always appears as the last digit of that actual number, and actual number is power of 10, so that is what it accounts for. Else if k is equal to 1, then it will be 1, because it will be the first digit in the 10 power of 10, whatever it is, so it will be 1. So and if k is greater than 1 or k is less than number of digits, then again answer will be 0, because excluding last one and the first last 0 and the first one, these things are all 0 in the actual number, right? So that's why it will be 0. And finally if it is greater than number of digits, so we will negate that number of digits from k. What am I doing here is that I am increasing actual number. I'm increasing actual number by 1 indirectly. How indirectly? So I want to start from the here. I want to surpass this 9. Means I want to start from here, start counting from here. So because I started, because I ended till here, right? Till the powers of 9. My actual number, okay, wait, did I subtract? Yes, k minus is equal to number of digits, so that's why i I aim to start from this thing after 10. That's why I subtracted k minus is equal to number of digits. And if k is perfectly divisible by number of digits, then you can easily derive this formula. It is not that difficult. And if not, if k is not divisible by number of digits, then we finally calculate how much numbers do we have to go ahead of the actual number to get the number which contains the kth digit, so the digit at the kth index. So finally k minus is equal to add star number of digits, means decrementing that k towards the uh, less than size of that number of digits. So finally string number, that actual number which contains the kth digit, and the number is equal to 2 string of actual number plus 1, because we have gotten to the number previous of that. So because this addition will not give the ceiling and will give the floor of the number, k divided by num of digits, so actual number plus 1. And this to string is the inbuilt function which converts the number to the string, which I have discussed in some previous videos as well. You can check them. And finally outputting the number of k minus 1. This is for minus 1 is for zero based indexing, taking considering taking the taking consideration of the zero based indexing. So that is it. See, this question was not that difficult, and this code can also be made shorter, and much shorter than this. But yes, it was not quite difficult problem. It was implementation heavy, and that too not too implementation heavy. But yes, I made pretty much of a wrong submission on these as well. A wrong submission on this question as well. But yeah, finally I got it right today. Yes. So I hope you enjoyed the video. Consider liking the video and subscribing to our channel. Nice to see you on the board. See you again, maybe. Yeah, make sure to come back.